Okay, now we're on to the converse of the Pythagorean theorem, where we're going to flip the logic. But first, as you can see, we are going to do warm up. Okay, so we're going to do a quadratic Pythagorean example. Obviously here you have the hypotenuse is 10, that has to be your C, and then a squared and b squared are interchangeable, but I would like you to pause and try this on your own first. Okay, welcome back. So a couple of main things people get messed up on. First of all, you do need parentheses around this for when you set up your Pythagorean equation. So you have x plus 2 squared in parentheses plus x squared equals 10 squared. The next place people mess up, and I'll do its own line and I'll do it in red. X plus 2 squared is not x squared plus 4. So you have to remember x plus 2 times x plus 2 is what this means. So you do have to FOIL. So here you get x squared plus 2x, and 2x is 4x, and then you have the plus 4. You have the middle term, okay? And a lot of people mess that up. So please take note that this squared is meaning this, and you do have to FOIL. Okay, so what we get down here is x squared plus 4x plus 4 plus the other x squared, this guy, equals 100. If you did mess this part up right here, I would suggest you pause again, erase, and try that. Okay, so combining like terms, we get 2x squared plus 4x. We have the 4, and then we're going to subtract 100. Okay, as we've talked about many times, if you can divide out a common factor in all of the terms, it makes your life a lot easier. So I'm going to divide out 2 everywhere. 0 divided by 2 is still 0, so you divide by 2 everywhere, and I get x squared plus 2x minus 48 equals 0. Factoring. So factor pairs of negative 48. Move this. So you got 1 times 48, 2 times 24, 3 times 16, 4 times 12. None of these are looking any good. I mean, 6 times 8 is it, isn't it? So 5 doesn't go in, but 6 times 8, you need 1 positive and 1 negative to get a negative 48. So, and we need a positive 2 when you combine like terms. So that's going to be a positive 8 and a negative 6. So minus 6 plus 8. So multiplies to negative 48, adds up to a positive 2. Okay, you're going to split these up. X minus 6 equals 0 means x is 6. X plus 8 equals 0 means x is a negative 8. Plugging into the picture, I cannot have a length of negative 8, so that one does not work. So it's just the x equals 6. Okay, you could plug in and make sure that seems right. This guy is going to be 6. This guy is going to be 8. 8 squared plus 6 squared is 100. So that checks out. So there's an example of a quadratic Pythagorean. We will do many of those. Triples. So the previous example was actually an example of a triple. And if you learn these triples, at least the main ones here, it will save you a ton of time. And that's even for like your SATs and that kind of thing too. So it is actually useful after this class as well to know these. So 3 positive integers that work in a Pythagorean equation are called Pythagorean triples. For example, 8, 15, 17 is a triple because 8 squared plus 15 squared equals 17 squared. So as long as you have all whole numbers, or positive integers, but whole numbers really, because you can't have 0 as a side length, you have a triple. Okay, so 3, 4, 5 works. 9 plus 16 is 25. Square root of 25 is 5. That is true of all of these listed. The other cool thing is, if you remember the basic ones, if you remember these basic ones here, any multiple of those is also a triple. So what you'll notice is 3, 4, 5 times 2 is 6, 8, 10. That is the same one we just saw on here. Okay. 3, 4, 5 times 3 is 9, 12, 15. Times 4 is 12, 16, 20. So this list can go on forever. So there is an infinite number of Pythagorean triples. Okay, there are more going this way as well. Another popular one is 9, 40, 41, but there are more in that direction as well. So any multiple is also a triple, and then realize that there are an infinite number of these triples. But you will see them everywhere. Converse. So converse is just flipping the logic. So the normal Pythagorean theorem says, if you have a right triangle, then a squared plus b squared equals c squared. You flip that logic and it says, if the lengths of the three sides of a triangle satisfy the Pythagorean theorem, so in other words, if a squared plus b squared equals c squared, and remember c squared would have to be the longest, so c is the longest, then you can prove the triangle is a right triangle. So that is what the converse says. So you're proving that it's a right triangle. So example, is a triangle with the following side lengths a right triangle? So here is my hint or suggestion. In crazy, radicals and stuff, it's sometimes not super obvious which one of these is the longest. So, because C has to be the longest. Now you can sort of reason through it, because 5 root 5 is 5 root 5 is going to be 2 point something. So that is obviously 5 times 2 point something going to be bigger than 10. So we do know that this is the longest. But what I would suggest you do is square all the numbers first. Because that'll always get you whole numbers. So then c squared is obviously the biggest. Or the largest, however you want to say it. Okay, so I would square all the numbers first. So what that looks like here, obviously this is 25. Okay, 5 root 5 squared is 25 times 5, which is 125. And then 10 squared is 100. Now you do have to be very careful, because what happens a lot of times is people square them to see which one is biggest, and then for some reason they square them again. So this is the squared. If you need to label them that they're squared, maybe I would suggest you do that, but these are the squared values. So now you're going to check, and the other hint I would give you is whenever you're doing the converse, this is going to come in handy in the next slide more. Whenever you do the converse, I would do the c squared first. It's more important for the next slide, but just get in the habit of doing that. So just flip the equation whenever you do the converse. So I would write in this case 125 is equal to 25 plus 100, right? That is true. So therefore, this is a right triangle. For some reason my pen is not acting correctly. So as long as those work in the Pythagorean equation, you have proven that the triangle is a right triangle. Okay, next thing, how to tell if a triangle is obtuse or acute. So as long as you put the c squared first, so the longest side length squared is First, it's actually very obvious what these answers are. So if c squared is greater than a squared plus b squared, then the triangle is obtuse. And that's easy to remember because an obtuse angle is larger than a right angle. So if c squared is larger, then it's obtuse. If c squared is smaller, then it is acute. Again, using the converse, I would put the c squared first. Okay, no, this is not in your book, but you do need to know it. So this information right here is not in your book, but you will be tested on it. So let's just try a couple of those. Again, these are fairly straightforward ones. So I'm going to let you pause and try them yourself. Okay, welcome back. So here, you're deciding if it's acute, obtuse, or right. Again, I generally just square them first. But obviously when they're whole numbers, you already know this is c, but that's c squared and then a squared and b squared. But I would please take my advice and put the c squared first. So c squared and then a squared plus b squared, you have to decide is equal, greater than, or less than. Well, 36 plus the 49 is what? 85? That seem right? Yes. So it's 85. So 81 is less than 85. So this particular one would be acute. Okay, on the next one. So squared, squared, squared. This obviously again would be the c squared. You have a squared and b squared. I'm going to put the 81 first, and then 9 plus 36. Here, what do you get? 45. So 81 is obviously larger than 45. So those lengths would give me an obtuse triangle. Okay, that's it for now. We'll see you tomorrow.